Alright, this lesson is going to be about 30, 60, 90 degree triangles. The objective will be I will learn to prove and apply properties of 30, 60, 90 degree triangles to find missing lengths. Okay, and we're going to start by looking at an equilateral triangle. And if you remember that equilateral triangle is also equiangular, so that means all the sides, all the angles, excuse me, are going to be 60 degrees. Now, I want to find the height of this triangle. So I want to come straight down. I want to bisect this 60 so that it becomes a 30-degree angle. Alright, and this is actually going to bisect this side right here. And we're going to be looking for the height. Alright, so what I'm going to do is I'm going to let this short side always be the x, which means since this height out bisected the side, this one is going to be twice as big, so I'm going to label that as 2x. Alright, so using Pythagorean theorem, we're going to say h squared plus x squared is equal to 2x squared. So if we go ahead and square that, that's going to give me 4x squared. I subtract the x, and then I need to take the square root of this, so that is going to be 3x squared. And so if I take the square root of 3x squared, the only thing that can factor or simplify is going to be this x squared, so I would have a pair of x's that come out of the radical. The 3 would stay inside. Alright, so what ends up happening, the pattern or the formula, what we just proved, is that this is going to be equal to x square root of 3 for the height. Alright, so anytime you're solving for missing length in a 30, 60, 90 triangle, this is what happens, or this is how we would label it. Your x is always across the 30. Your hypotenuse is 2x, and across the 60 degrees is going to be x square root of 3. If I rotate it, it doesn't matter, it stays the same. Across the 30 is my x, the hypotenuse is twice as big, and then the side, the longer leg, is going to be x square root of 3. Right, so like before with the 45, 45, 90, the x is always across the 30 degrees, x square root of 3 is across the 60, and across the 90 is the 2x. Right, so let's look at this example here, and we're going to find the length of LM and the length of MN. The only thing they gave us was the hypotenuse being LN. Alright, so let's see, if we go 30, 60, 90, let's go ahead and make a table here. I know this is x, x square root of 3, and this is 2x. Okay, and then the one they gave us was the across the 90, which is the 14 here. So I know this is my 2x side. So 2x equals 14 means x is just 7. So my 7 would go here, which is going to be my MN side. And this one is going to be 7 square roots of 3. Alright, so here we go. We're going to look at another one. If this is 90 and that's 60, that means this angle over here has to be 30. Right, so again, if you want to build this little table to kind of help you keep straight of what is equal to what, crosses the x, x square root of 3, and 2x. Okay, and then across the 30, that's the 2 square roots of 5. So I know x is equal to 2 square roots of 5. So that means that LM, this side right here, is going to be equal to x square root of 3. So I'm going to replace the x with 2 square roots of 5. So I got 2 square roots of 5 times the square root of 3, which is going to be equal to 2 square roots of 15. Since both of these are prime, they're not going to factor or reduce. This is the length of LM in lowest terms. Okay, then I'm going to take 2 times 2 square roots of 5, and that becomes 4 square root of 5. All right, one more example, or the next example. All right, let's see, 90 and 60, that means the 30 is right here. So this is going to be my x side. This would be my 2x side. And this is my x square root of 3 side. So I know x square root of 3 is going to be equal to 8. I have to divide both sides by the square root of 3. We can't have the radical in the denominator, so we got to multiply top and bottom by the square root of 3. Okay. 8 and 3 do not factor, so that is the length of x, which is going to be the mn. So this is 8 square root of 3 over 3. Okay, and then ln is twice of that. If I multiply that by 2 over 1, 8 square root of 3 over 3, that's just going to give me 16 square roots of 3 over 3. That doesn't reduce, so this is our answer. Alright, and the last example, using this 30, 60, 90. Across the 30 is always going to be x. 60 is x square roots of 3. And across the 90 is my 2x side. Again, if you want to use the table, okay, they gave us the one across the 90, which is 4 square roots of 3. So that's what I'm going to set equal. And divide both sides by 2. Which we said was the NM side. Okay, and then LM is going to be equal to 2 square roots of 3. That's my x times the square root of 3, which is just going to be, if we want to do 2 square roots of 9, which is just 2 times 3, which is 6. And so LM is 6.